Okay, the last thing we're going to do here in Mod 7 is to take a look at a histogram. So a histogram is probably a more common way to visualize the distribution of our quantitative or our numeric data. The dot plot is really nice because we can see a dot for each piece of data. Although honestly, if you have a lot of data in StatCrunch, they honestly will oftentimes give you a note that says each dot represents 3 pieces of data rather than just one. But you can see the individual pieces of data above the number line there. The histogram doesn't give you quite as much detailed information because data gets grouped into classes, and each class of data represents a specific interval on the number line. And then what the histogram is going to tell us is how many pieces of data fall in that interval. But what a histogram does really nicely is let us identify that shape and other specifics about our distribution. So let's see, number 7 is asking us to draw a histogram again of that calorie column that we were just looking at in the dot plot. A histogram is another kind of a graph, so that's where we're going to start. We'll pick histogram and the calorie column. For right now, I'm going to go ahead and just click compute. So this is a histogram. It looks a lot like a bar plot, but a bar plot in statistics is actually something very different. A bar plot still has bars, but a bar plot is not for numeric or quantitative data. Notice that here, because StatCrunch knows this is numeric data, there's an empty spot here. We have 3 pieces of data that are falling in that interval from 50 to 60, but then there's no data falling in that interval from 60 to 70, so we see that open break. I'm going to go back into StatCrunch for a minute and choose a bar plot so you can see the difference. I have the data. The data is in my calorie column, and compute. Now, while we're getting a similar overall shape, what's really important is to notice that we're missing this gap. Notice how 50 is here and 70 is right there. The same amount of space from 50 to 70 as we see from 70 to 80 and 80 to 90. Because in a bar plot, StatCrunch is assuming that each one of these numbers is actually just a label. And when they're labels, there's no reason not to put 50 and 70 right next to each other. It's only if they're numbers that we need to leave this open space for the missing numbers that we have. So even though it does still give us the sense of the bell shape, you're going to miss important details if you choose a bar plot when you have numeric quantitative data. You must choose the histogram. Okay, so here's our histogram. As you see, while I move my cursor over the histogram, I can get some information about each one of those bars. The frequency, so that's the number of data pieces. We can see that 17 cereals have a calorie amount between 100 and 110. And I want you to notice the very specific way that that interval is given to us. Notice that it has the close bracket on 100, which means a cereal of 100 calories could be in that bar. But then there's that round parenthesis on the 110 on the right-hand side. That means that a cereal with a calorie amount of 110 would not be in this bar. The next bar, that starts at 110, but with a closed bracket, indicating that 110 would be in that interval. So every time you see a histogram, note that the left-hand endpoint, that value is in that bar. The right-hand endpoint is in the next bar. Okay, let's take a look at what we've got here. The first thing we're asked is what percent of cereals have a calorie amount less than 80? Okay, well, 80 is here. So let's take a look at the two bars that are meeting that criteria of less than 80. In the interval that goes from 50 to 60, right? Could equal 50, wouldn't equal 60. That has a count of 3. 60 to 70 is no data, but let me just put there so we're keeping track of everything that's going on, making sure everybody's following. And then from 70 to 80, we have, let's see, what is that? 2 pieces of data. Yeah, frequency of 2. Notice when I clicked on it there, those bars actually turn a color. If you don't like that, let me bring the bottom of the screen up. You can click here to clear the coloring that's been done. Okay, so that was a count of 2, so that means we have a total of 5 cereals that have a calorie amount less than 80. And as a percent then, it is 5 out of 77 cereals, if we remember that there were 77 cereals. So then we just need to divide. 5 divided by 77 is 0.06. Let's see, let me give us a bunch of decimal places here. 0.64935. I didn't include rounding instructions here. To change to a percent, we multiply by 100, which means we have to move our decimal point 2 places to the right. And then let's say we want to round our percent to 1 decimal place. So we're going to round here. We look 1 place to the right. If to the right you see a 5 through 9, this digit increases by 1. So this is 6.5%. With the rounding, if this 1 digit to the right had been a 0 through 4, we would leave this digit alone, but we needed to increase it because of the 5 that was to the right. So our answer is 6.5% of cereals have less than 80 calories per serving. Okay. The next question, what if we change to a relative frequency histogram? Well, a relative frequency is really this percentage that we calculated above. So a relative frequency gives us the proportion of data that is in each class. And we find that by taking the amount of data in that class and dividing by the total amount of data. So let's just take a look at what would be in our first few classes. From 50 to 60, our first bar, our relative frequency would be 3 over 77. That is, let's just do 2 decimal places. 0.0, well, you know what, I used 3 up here. Yeah, let's just stick with 2. So 0.04. From 60 to 70, we know is going to be 0. From 70 to 80 would be 2 divided by 77, which is 0.03. 3. That actually came out 025. So the 5 changed my second digit here to a 3. All right, I don't want to go through them all, especially when StatCrunch will do it for us. So I want to show us a few things in StatCrunch. I'm going to go back to the options. Display options. If I click here to have the value displayed above the bar, well, that would have made my life a little bit easier when I was trying to see how many pieces of data were in each one of these classes. So that's an option that you have. We're going to go next, though, to type, and instead of a frequency table, we're going to make a relative frequency table. So now our vertical scale, the height of each bar, is going to be the relative frequency of data in that class. And I've left that display over the bar here so you can see 0.04, just like we calculated here. 0, we have no data, and then 0.03, just like we calculated here. The other thing that I hope you notice about this is that the shape is exactly the same between that frequency and relative frequency histogram. I'm actually going to go back and get the frequency histogram and just put it side by side so you can see how identical they are. There we go. So the thing that has changed is our vertical scaling, but you know, how the data is laid out throughout its range is exactly the same. So changing that vertical scaling does not change the distribution of our data. The last thing I want to show you is how much the width of these bars can affect what you see in that picture. And I want to show you that really as a cautionary tale to why we don't get bogged down in the details and instead just look for overall trends. I'm going to close these histograms and I'm going to go here to applets. So we're never using applets to make a histogram to calculate anything. Applets are just for us to explore. So we're going to go here and explore using a histogram with sliders. I'm still going to use the calorie data. I'm not going to worry about these other things and click compute. So notice what we start off with is exactly the same histogram that StatCrunch made for us a while ago. If I change the starting point, I can kind of move that graph a little bit left and right. That doesn't make a very big difference, but changing my bin width here, that is going to make a difference. So the bin width is the width of each one of these bars, the interval of data that is included. So as I make that smaller and smaller and smaller, we get fewer bars, and now they're kind of pulled apart because of the way our data is. That didn't really come up with too much of a change, but look what happens as I make those bars bigger and bigger and bigger. Now we can see so much of that data is just right in the center there and very little kind of falling out on either side. It's still a bell shape, but we maybe feel different about that bell. And then, well, now it actually looks a little skewed, right? I've got so much data to the right, hardly any to the left. That really has a very different feel from the bell shape. And well, now it's sort of the opposite. Now I have just a little bit of data that falling to the right of that great big bar. So just notice how much that shape varies, how that big peak in the data varies from the left to the right hand side of the scale as we change that bin width. So every time you're assessing the characteristics of your histogram, just don't get too attached to very specific things you see there. Stick to things that are more general.